Interference and diffraction. Interference is due to the superposition of waves originating from two separate slits which are acting as coherent sources. Whereas diffraction is due to the superposition of wavelets originating from a wavefront coming from a single source. As a result of interference of waves coming from two separate sources, we get interference pattern. In this interference pattern, the white and dark fringes are of equal width and equal intensity. That is, all white, the maximum intensity regions have the same width and same intensity. But in the case of diffraction pattern, we can find that the maximum intensity regions, they are of varying intensity, and the intensity decreases as the order increases. So we can compare, or we can make a distinction between these interference patterns and diffraction patterns. In the case of interference patterns, first of all, interference is due to the superposition of waves originating from two separate slits which are acting as coherent sources. And the diffraction, it is due to the superposition of wavelets originating from a wavefront coming from a single source. So in the case of interference pattern, there exists a very large number of fringes. That is, on either side of the central maximum, we will be getting a very large number of fringes. And in the case of diffraction pattern, on the either side of the central maximum, we will be getting only a few fringes. And in the case of interference pattern, all fringes are of equal width. And in the case of diffraction pattern, fringes are of unequal width. And in the interference, there exists sharp boundary between the fringes. That is, we can identify the boundary between a dark and bright fringes very clearly. And in the case of diffraction pattern, the boundary between the fringes is not sharp. So this is evident from this pattern. Here the boundary between the bright and dark regions, it is not that much sharp. And in the case of interference, we know the minimum intensity band can be of zero intensity. That is, if we are using two sources of equal amplitudes, the dark regions will be perfectly dark. And in the case of diffraction, the minimum intensity is not zero. And in interference pattern, all maximum intensity bands have same intensity. Means these white regions, the peaks, they are at the same intensity level. And in the case of diffraction pattern, the maximum intensity bands, they have varying intensity. Intensity keeps on decreasing as the order of the fringes increases. Intensity distributions of interference pattern and diffraction pattern can be represented in a graph. In the case of interference, we have already seen that when the phase difference is odd multiples of pi, 3 pi, we will be getting minima, and for even multiple 2 pi next, that will be 4 pi, we will be having maximum intensity. And in the case of diffraction pattern, we have seen that if waves are emanating at an angle theta is equal to lambda by a, That is, if the light waves are diffracting at an angle theta is equal to lambda by a with the axis of the slit, we are getting the first minimum. And in the case of diffraction pattern, the width decreases, also the intensity decreases as the order of the fringes increases. So in this way we can make a comparison or a distinction between the interference fringes and diffraction fringes, the interference patterns and diffraction patterns.